So as we decided, we will go for discussing about family of circles. Earlier we have gone through family of curves. We have seen that whenever we nurture with more than one curve with certain parameters common in all the considering curves, then they are said to form a family of curves. Earlier you have addressed family of straight line. Now we are going to address family of circles. So before we go for formal introduction to family of circle, even unknowingly we have covered certain type of family of circles. Like you can recall that we have discussed about concentric circles. So we can even think of a group of circles with having their center same at a fixed position. They can form a concentric family of circles. We have also identified the condition that if a circle touches x-axis, then from the standard general representation of the circle in the form of x square plus y square plus 2gx plus 2fy plus c is equals to 0, it must satisfy g square is equals to c. So we can also think of all the circles which touches x-axis tangentially. They can form a family of circle. Means in all their equation, which will be common criteria, is g square is equals to c. On a similar note, if we consider of circles which are touching y-axis, they will form a family, and so many other possibilities also. Now over here, we are going to address the family of circle for a specific form in 4 variation. So let us firstly have the 4 variation and then we will conclude about it. So let us go for the first family. So over here, the first formation we are addressing is circles passing through the common points of a given line, say Lx plus My plus n is equals to 0, marked as L is equals to 0, capital L is equals to 0, and a given circle S as x, a given circle S is equals to 0 with the equation x square plus y square plus 2gx plus 2fy plus c is equals to 0. Now over here you can identify we are talking about common points. So that means we can believe the straight line is intersecting the circle at 2 points. Okay. So we are not talking about any contacting line. We will discuss firstly about this and then we will decide if the line is contacting, means if there is a single point common in a as a point of contact, will the conclusions be holding or not. So we are going to determine all such circles which can pass through their common points. So if we have even 2 points of intersection, then we can have infinite circles passing through both these points. We know that a circle can be particularly identified or uniquely identified if it has to pass through 3 non-collinear points. But over here, when we are going to get only 2 points, we can have variation over the size of the circles, and keeping the 2 points common, we can have infinite such circles. Now, if we try to address all such circles, the common algebraic identification for all of them is they are going to be some second degree polynomial equation in 2 variables x and y, and it should be such an expression which must be true for the coordinates of common points of this given line L is equals to 0 and the given circle S is equals to 0. And also we can conclude the family of circles we are about to describe, it must have the trivial member as S is equals to 0 itself. It is also a circle which is going to pass through those considered points. So targeting the algebraic speciality that we are looking forward to a second degree polynomial equation where there will not be any xy term as per the requirement of circle, and the coefficient of x square and y square will remain the same. And moreover, due to the common points coordinate for L is equals to 0 and S is equals to 0, it must be satisfied. So keeping the ideas into mind, we have gone for a constant combination of this S and L. Like if I go for lambda 1 S plus lambda 2 L is equals to 0, then we can identify this is going to be one such algebraic equation, which is definitely of degree 2. There will not be any xy term because neither S nor L has any xy term. As such, L is a 1-degree polynomial in x and y. S was satisfying all the conditions of circle, no xy term, and coefficient of x square and y square same. So even if we multiply it with lambda 1, this will be true. So lambda 1 S plus lambda 2 L is equals to 0 will give us such an algebraically found second degree equation, second degree polynomial equation in two variables x and y, which satisfy the necessary conditions of representing a circle. So all the circles which can be passing through P and Q, this common points, for them we can follow this restriction. Now over here you can identify lambda 1 cannot be 0 and lambda 2 can be any real number. As such, lambda 1 can be any non-zero real number and lambda 2 can be any real number. Now why lambda 1 cannot be 0? Because if I make lambda 1 0, then we are going, and lambda 2 non-zero, in that case we are going to get L is equals to 0, which is not a circle.
Yes, sir.
So to ensure that this representation stands for a circle, we must have lambda 1 non-zero real number and lambda 2 as any real number. Because lambda 2 can be 0, that will give you back the S is equals to 0 trivial member. And as we are getting lambda 1 non-zero real numbers, we can have a division of the whole equation by lambda 1 and can get it with a single parameter in the form of S plus lambda L is equals to 0. So we can conclude that if we are treating a circle, S is equals to 0 and a given line L is equals to 0, then any circle which can pass through their point of intersection can always be represented as S plus lambda L is equals to 0. Now look here, in the process of description, have we ever used that there were two common points? Or even a single point of contact will do this job? Because all we wanted is such a algebraic association which will be true for the common point. So the association has never pointed out for the fact that there has to be common points and it cannot be a point of contact. So we can believe even if there is not two distinct points in common, but instead we do have a tangential point of contact, still this idea will be true.
Yes.
And this has given us a very easy conclusion that for S is equals to 0 given circle and L is equals to 0 given line, we can always think of all possible infinite circles that can pass through their common point or points be represented as S plus lambda L is equals to 0. So when we move to this next category, that circles passing through two given points P and Q, say P is with coordinate x1 comma y1 and Q is with coordinate x2 comma y2, then we can again search for a reference circle S is equals to 0 and a reference line L is equals to 0, right? If we are able to get so, we can again represent the family of circle as S plus lambda L is equals to 0. So when only 2 points are given, what we have done, we have considered of the unique line that can pass through both these points. Like these 2 points were given, so we have considered the line which can pass through both these points. We are able to determine the equation in 2-point form. So we have found our required L is equals to 0 as y minus y1 by y2 minus y1 minus x minus x1 by x2 minus x1 is equals to 0. So with this equation, we have found the unique straight line passing through both the points. As such, we could have infinite possible circles passing through these 2 points, but with the help of 2 points, if we need to determine a circle, it will be easy if we consider the circle with those 2 points as diametric extreme. And hence, we have created our reference of S as treating P and Q as diametric extreme. So the equation we have found is x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equals to 0. And as soon as we have formed these two equations, now the description can be readdressed as we are searching for those circles which pass through the common points of this S is equals to 0 circle and this L is equals to 0 line. And hence, again, we can have the format of representation S plus lambda L is equals to 0. Is that okay with everyone?
Yes, sir.
So far, any problem to follow?
No, sir.
No, sir.
No, sir.
So we are capitalizing the first information S plus lambda L is equals to 0. Okay. And when the information is not supporting that fact, we are creating such references so that we can follow it comfortably. The third variation is circles passing through common points of two given circles, S is equals to 0 and S dash is equals to 0. So over here, instead of one circle, we do have two reference circles, but what is missing is a given line. Now, can we identify a line which will pass through their common points? It is supposed to be their common chord, which
Yes.
is also by its extension the radical axis for the circles. And hence, we can think of the line of this reference can be described as L, which is S minus S dash is equals to 0. So these are these two circles. S is equals to 0 and S dash is equals to 0. So they have common points P and Q. So PQ is the common chord and extension of PQ is the radical axis. And we earlier decided that radical axis and common chord, theoretically they may be different, but equation wise they are part of same line and hence will follow same equation. So as soon as we have got the reference line as L is equals to 0 given by S minus S dash is equals to 0. Now ahead you can use S as your reference circle and can describe the family as S plus lambda L is equals to 0. Or also you can use the second circle S dash as your reference circle and have the family as S dash plus lambda L is equals to 0. Whereas we do also have an alternate choice, like earlier we have decided what we are searching is algebraically a second degree polynomial in x and y to be found from the given reference curves. And hence, like earlier also, we can think of a constant combination of the two given circular expressions and equate it with 0. So we can also have a representation in the form of lambda 1 s plus lambda 2 s dash is equals to 0, where lambda 1 and lambda 2 could have been any real number. If lambda 1 is 0, we will get the trivial member s dash is equals to 0. If lambda 2 is 0, but lambda 1 is not, then we will get the trivial member s is equals to 0. But remember in the earlier reference, what lambda we have written in this particular part, over here, the lambda should not be 0. Okay, so let us mark it. In this part, lambda must belonging to non-zero real numbers. Okay. In the second part, when we have gone through this constant combination, now we can have any one of lambda 1 or lambda 2 to be 0. If one of them is 0, then we are going to get one of the trivial member of the family. And hence, for non-trivial member, we can even reduce the number of parameter by dividing it with lambda 1 and can get the representation as s plus mu s dash is equals to 0. Over here, mu stands for lambda 2 by lambda 1. So just to reduce the number of parameters, we can also have such a formation. Now, why we are taking these references when we already have that? When we are creating references, then it's okay for us. But in a question, we might be given with different variation. So in a question, you might be given with a family of circle which is not matching any of this format, but follows such a possible representation, or maybe even this representation. So two parameter based representation or one parameter based representation, but the reference equations are both circular expression. So there also we must not get any kind of difficulty to conclude the same family of circle and to identify it properly. Okay.
Yes, sir.
The last and the fourth variation is circles touching a given line L is equals to 0 tangentially at a given point P, and we are assuming that P is given with the coordinate alpha comma beta. So as per the diagram, we can have such possible representation. So over here, we do have the reference of line as L is equals to 0, but the S is equals to 0 reference was missing. So what we have done, the point which was common in both all the circles and the line, we can consider of this point P as a point circle S, which can be described as x minus alpha whole square plus y minus beta whole square is equals to 0. And through this mode of representation, we can readdress the family as family of circles passing through the common points of S is equals to 0 and L is equals to 0, and hence can be represented as S plus lambda L is equals to 0. Okay with everyone?
Yes, sir.
So all the descriptions are clear for all?
So can you explain the fourth one again? I didn't get this.
Yeah, like in the fourth one, we are not given with any circle, but we do have the reference of a line, but we are not been given with any circle S is equals to 0, for whom and L is equals to 0, common points or common point is common in all the considered circle. So that is why we have considered the given point alpha comma beta as a point circle and created the reference of S is equals to 0, so that we can describe it in the first format, that we are searching for circles which are passing through the common points of S is equals to 0 and L is equals to 0, hence can be described as S plus lambda L is equals to 0.
Okay.
Next, note down, if we get such a family of circle where irrespective of our selection, any pair of circle.
Sir, this is Pranjal, sir. My computer, I tried, sir, but it's still crashed, keep
Okay,
crashing.
just
I
go
came
through
up,
the class note.
my video is on, sir. Okay, sir.
Where irrespective of our selection, any pair of circles will possess fixed straight line as their radical axis. Then the family is called coaxial family of circles. Okay. So what has been stated, if we address a family of circles where irrespective of our selection, any pair of circles will possess fixed straight line as their radical axis, then the family is called coaxial family of circles. Means you can select any two circles from the family. What radical axis you will get, that will stay the same if you select a different pair of circles. So you can identify all the four above mentioned families. These are all coaxial family of circles. Let's have a look right from the first family. Over here, if you consider the circle and the line, and hence other circles which are also going to pass through P and Q, they all will have their common chord along L is equals to 0, and hence the radical axis will stay the same, as all the circles are going to have P and Q common. If you consider the second variation over there, it's already been said P and Q are common in all the circles. So again, the radical axis will be fixed. In the third one also, we have described it by the radical axis itself. And the fourth one also, over here, any two circle is either externally contacting or internally contacting, and hence the common tangent through the common point, it may be the only possible common tangent in case of internal contacting, or it might be the common tangent through the common point for external contacting pairs. But in any way, the radical axis remains the same. So all these four families are following the coaxial description. So mark all the above mentioned families are coaxial family of circles. Now you might have a query that if all these families are appearing like coaxial family of circles, then how can be family of circles which are non-coaxial? So over there you can think of the concentric family of circle. Definitely no two of them will even have a radical axis. So definitely it's not a coaxial family. Or even you can think of such a diagram. Okay, this can be example of a non-coaxial family of circles. Is that okay with everyone so far?
Yes, sir.
Yes, sir.
So instead of 2 points common, if we think of circles with exactly 1 point common, then it's not going to be a coaxial family. But the 4 variation we have gone through are all coaxial family of circles. Now the question arises, on the basis of this theory, what type of problems we need to solve? So let's have a look in that variation also. In all the problems where we need to apply the ideas of family of circle, the description of the question will have overall segregated into 2 parts, where one part of data or information that will be identically matching with the descriptions of family of circle, and there will be the other section which will be the additional information. Like you have gone through this information. If we do have any of this 4 information, we are not going to have any 1 or 2 circles, but infinite number of circles. a complete family of circles. So when we will be given with a question, it will be a query associated with identification of an unique circle or maybe certain finite number of circles. So over there, apart from this general description, there will be some additional information also. Let us have a look what type of problem and what information we can have. Like the first question over here been given as a circle touches y is equals to x or y minus x is equals to 0 at 3,3 and also touches x-axis. Find its possible equation. Now, if you look into this description, you can identify touches y is equals to x at 3,3. This is matching with the fourth family of circles or fourth description for family of circles. Whereas the additional information is this circle we are searching from this family is also touching x-axis. So we have divided the whole information set of the question into two parts. One is theory matching description of family of circle and the other part is additional information. So how can we start with? We can think of starting in the form of s plus lambda l is equals to 0. Here s will be the reference of x minus 3 whole square plus y minus 3 whole square and l, as you can find, is y minus x. So we have got s plus lambda l is equals to 0 as the family of circle. Now we know that a circle will touch x-axis if in the standard general representation of the circle we should have g squared is equals to c. So we have transformed the equation in the standard general form. And now the coefficient of x, that will be the reference of 2g. And this 18 is the reference of c. And hence we can go for x-axis, contacting x-axis tangentially. Half of 6 plus lambda whole square is equals to 18. That's the g square is equals to c criteria. And hence solving it, we can get to the values of lambda which can satisfy. And once you have lambda, we can complete the equation of the circle. Is the information clear to all?
Yes, sir.
Yes, sir.
Yes, sir.
I'm also describing another one. So over here, the information is the intercept on the line y is equals to x by the circle x square plus y square minus 2x is equals to 0 is AB. Find the equation of the circle having AB as diameter. Now over here, the question, this can be identified in two variations. The first variation is without using family of circle. Like this circle is quite easy equation here and the line is very, very special. So we can even go for determination of the coordinate of A and B by associating the line and the circle, as it is going to be very easy here. And hence,
Yes, sir.
after having A and B, this circle will AB with AB as diameter can be found in diametric extreme form. But now I am showing you the same solution when we are segregating it in the family of circle idea. So I am not showing you the trivial idea with which it can be even solved faster. Just to have your correlation with the family of circle, firstly we will go for the intersection of the line y is equals to x and x square plus y square minus 2x is equals to 0. These two are our given L and S, and we are searching for that circle which will be belonging to the family S plus lambda L is equals to 0. And if AB is its diameter, it is the smallest member of the family. So accordingly, what we have gone for, firstly we have gone for this S plus lambda L is equals to 0 description and transform the equation in the standard general form. and then we have decided the radius. Now, if we minimize the radius, that will give us the required member. So we have transformed radius in this form, which is conclusive that it will be least if lambda is -1. So for
Yes,
lambda
sir.
is equals to -1, we are going to have the smallest member of the family, or this circle, which will be having AB as diameter. Okay. So the required circle will be x square plus y square minus x minus y is equals to 0. Now let us have another example where we will have the idea that if we do not have equation of circle in that special form and still we do have a similar query, then what to be done? So now we are searching for the smallest circle passing through the intersection of the line. This is intersection of the line x plus y is equals to 1 and this circle x square plus y square is equals to 9. So that's family matching description, right?
Yes, sir.
Whereas the additional information will be treated as smallest circle. Okay, so we will get to the family of circle, and then again having the radius. If we minimize the representation, again we have got for lambda is equals to -1, we are going to get the smallest member, that is x square plus y square minus x minus y plus 8 is equals to 0. Okay, so this is
Yes, sir.
also a similar example as the earlier one. Is it clear this far?
Yes, sir.
The next example is the equation of the circle passing through.
Sir,
Yes,
sir, can you scroll up a bit?
yes, you can go through this part. Is that okay?
So can you please explain again what
Yes,
we
sir,
did?
thank you.
What we did for finding out the smallest circle?
Okay, if you consider a family of circle passing through two given points, okay, we can draw infinite circles passing through two given points. Now, what will be the smallest circle that will be passing through that two given points? Will the 2 points be special for that specific circle, which will be smallest in size?
Will be the diameter.
Will have diameter. So if we consider a family of circle passing through two given points and asking for, and we are also finding the smallest member from the family. So either we can go on deciding the points coordinate and have the smallest member described in diametric extreme form, or otherwise we can go for any general member from the family in terms of s plus lambda l is equals to 0, have its radius in terms of lambda, and as it is the smallest member, the size of a circle is controlled by the radius. So if we minimize the radius, that will give us the smallest member. So when we have gone for transforming the radius representation into this form, we can identify for lambda is equals to -1, this expression will be minimum. And hence the smallest member can be found for lambda is equals to -1. That is the circle x square plus y square minus x minus y plus 8 is equals to 0. Now in the next question, the equation of the circle passing through 1, -3 and the points common to x square plus y square minus 6x plus 8y minus 16 is equals to 0 and x square plus y square plus 4x minus 2y minus 8 is equals to 0 is given as s is equals to 0. We need to determine s. So we can identify here that we are having the family of circle description in the form of common to two given circles. It is the third description matching form.
Yes, sir.
Okay. And the additional information here, passing through 1 comma minus 3. Okay. So as two circles are already given, we can have the family of circle described as is plus lambda is dash is equals to 0, that variation. So we can go for lambda association of the two expression and equate it with 0. So this is a possible representation for the family of circle. And we are searching such a member which should pass through 1 comma minus 3. So that means for the required family member, this equation should be true for substitution of 1 comma minus 3.
Yes, sir.
Now if you substitute 1 for x and minus 3 for y, that gives us this relation to follow. That is 12 lambda is equals to 36 or lambda is equals to 3. So if we substitute lambda is equals to 3, we are going to get this circle described as 2x square plus 2y square plus 3x plus y minus 20 is equals to 0. This will be our required circle.